MacMaths, let's do some maths today. Okay, carrying on with our series of lessons on variable acceleration. I've just done one lesson on the whole chapter, and so this is just some support for the different exercises. I haven't done support for exercise 11a. You can do that if you want. It's just sticking numbers into formulas that it gives you. That's all it is really. So the math starts getting a bit more interesting when you get to 11b. 11b is very simple as well. So I'm just going to go through a couple of questions with you. That's all from that exercise. Okay, can I just remind you then of what we've learnt? We've learnt that when we've done this, we've learnt that if we start with displacement, we've got any formula for displacement, we differentiate to get the velocity and we differentiate to get the acceleration. And I want you to get used to seeing the velocity as ds by dt, because this is in terms of t. So, and then the acceleration is d2s over dt squared, but also that differentiated, the velocity dv by dt. Okay, so the acceleration can be described as this or this. The velocity can be described as ds by dt, the change in displacement with time. But we differentiate going that way, and we integrate going that way, but that's in the later ones. Okay, so let's just start with exercise 11b. Only going to do the first ones. Don't really get why they do this, by the way. But here, find an expression for the velocity and the acceleration of a particle given that the displacement is this. Well, this to me looks a sensible equation. It's only asking for an expression, so s equals 4t to the power of 4 minus, and I'm going to change that 1 over t to t to the minus 1, so move that t up, so we've got it into something that we can differentiate. And then s, we want an expression for the velocity, so if we differentiate it we get the velocity, so ds by dt, or the velocity. So 16, 4 fours are 16t cubed plus t2 and not 1 off the power at minus 2. So you can leave it like that if you want, or in the back of the book it might be 1 over t squared. And that's it. Okay, simple as that. And for b, I don't know why it uses x here, but it says the displacement now, it's describing it as x. Displacement along the x-axis, I suppose. And again, I'm just going to change this plus t to the minus 2. So I've moved that t squared up to be t to the minus 2. And then if we differentiate, oh sorry, I wanted the acceleration. If we differentiate this, then the velocity is going to be 2t cubed, 2t squared, in fact even, minus 2t to the minus 3. Okay, so that's the velocity and the velocity, and then if we want to go down another step to get the acceleration, we can go 48t squared, can't we, minus 2t to the minus 3, and again we can write that differently if we want. We can write the t cubed underneath there, and this one, acceleration, is 4t and plus 6t and not 1 off to the minus 4, and I'm just going to leave it like that. There is a part C and a part D, just doing the same as that, we're just differentiating twice. Okay, and there we go. And again, I could write these different, couldn't I? I could write that as dx by dt in this case, or d2x over dt squared if I wanted to, and so on. Okay, but I've chosen to stick with SV and A, SV and A, SV and A. Okay, so that's question 1. Question 2. I'll leave that there at the side. Question 2 is probably a little bit better. A particle is moving a straight line at t seconds. Its displacement is x from a fixed point O given by, so this is, it's describing sort of on a graph here, where it's like moving along the x-axis. So x is 2t cubed minus 8t. Find the velocity when t is 3. Well, what is this? This is the displacement, so this is s. s equals x equals 2. Okay, so let's just change it and think of it as s, because now we know what we're dealing with. Find the velocity when t equals 3. So the velocity, if we differentiate down, okay, ds by dt, or velocity, is 6t squared minus 8, and when t is equal to 3, putting 3 into there, we're going to get 3 squared is 9, 6 9s are 54, minus 8, so the velocity is going to be 46 meters per second to the minus 1. Okay, the acceleration when t is 2, so that's part A. Part B, sorry, that's my daughter's arriving, they're slamming the door, the car. So we've got the velocity. If we differentiate, we get the acceleration. So here's our velocity. So if v is equal to 6t squared minus 8, then the acceleration, or dv by dt, is going to be 12t. The minus 8 goes, so simple as that. And when t is equal to 2, the acceleration is going to be 12 times 2, which is 24 meters per second to the minus 2. I only need to do 1 and 2, the others are just differentiating down and just changing your letters accordingly. You're switching between, maths from graphs, your y and your x, really thinking about y and x and doing what you've always done all your lives with, y equals mx plus c and function, and not just straight lines, but obviously functions in terms of y and x, Cartesian graphs, and applying it to real life. That's what we're doing. So we're looking at different letters to describe the y-axis and the x-axis. Okay, there we go, short lesson. Have a go at those on 11B.